Welcome back to our coverage from AWS reInvent 2019. We're live on AWS Launchpad, bringing you the latest from the show. This is AWS's Customer and Partner Conference here in Las Vegas, which we run every year. My name's Ian Massingham. I'm in the AWS Developer Relations team, and as usual for this next segment, I am joined by a few special guests. So would you like to introduce yourselves, first of all?
Hey, my name's Ketan. I'm an engineer at Lyft. I lead the machine learning and data infrastructure platform.
Great.
My name is Aditya Bindal. I'm a senior product manager with Amazon Machine Learning.
Hey, and I'm Marcia. I'm technical evangelist for AWS.
Great, and in this next segment, we're going to be diving into a new launch, which we announced slightly earlier this week here at reInvent. And it's a launch that combines two of the hottest topics in technology today, machine learning and containerization and container orchestration. So really hot topics. And I'll turn it over to you, Aditya. Could you tell us a little bit more about what you've announced this week, first of all?
Definitely, Ian. So earlier this week, we announced Amazon SageMaker Operators for Kubernetes. And these operators bring together for the very first time SageMaker and Kubernetes. So we're bringing all of the managed services and power of Amazon SageMaker to train, tune, and deploy machine learning models from your Kubernetes cluster.
You mentioned Kubernetes operators there, and that's a pretty new concept. So could you first of all just unpack that a little bit and explain to the audience precisely what they are?
So Kubernetes operators are a way in which you can extend the core Kubernetes API. So if you want to bring your own custom resources, your own custom controller, that still allow you to use the standardized Kubernetes interface, so tools like kubectl, writing configuration files, building these repeatable pipelines and taking these primitives, operators are a way you can extend what Kubernetes gives you out of the box. So what we've done is we've built SageMaker custom resources within a Kubernetes cluster and a SageMaker custom controller. And that allows you to orchestrate all of your machine learning workloads from Kubernetes, but executing and running in SageMaker. So you don't need to do any of the heavy lifting in managing the underlying infrastructure in your Kubernetes cluster. You get all of that from SageMaker.
Great, and of course at AWS and at Amazon, we always work backwards from customer problems and try to create products and services that solve those. So can you talk a little bit more about how customers are using Kubernetes and SageMaker today, and how this particular new service helps solve some of the problem cases that customers were describing to us?
Definitely. So we have two different types of customers within a company. You have a platform, infrastructure, and DevOps team, and then you have data science teams. And data science teams love the tooling and all of the environments SageMaker provides. They can work in Jupyter notebooks, they can train their models in TensorFlow, MXNet, PyTorch, they can deploy them into these fully managed auto-scaling endpoints. But then DevOps and platform teams will use Kubernetes, not just for managing pipelines, but for managing the overall application that goes beyond just machine learning. And by bringing these two together, we satisfy that core need where I want to orchestrate and build repeatable pipelines in Kubernetes, but I don't want to actually manage the underlying infrastructure. I don't want to have to create GPU instances and update them every time there's a new version of NVIDIA libraries or TensorFlow. So I want that entire machine learning training, tuning, and inference experience to be managed, but I want to retain the control, the portability, the flexibility that Kubernetes gives me so that everyone can compose their jobs and orchestrate in a standardized way. And that's exactly why we build these SageMaker operators.
Great. We're taking questions during the stream, of course, here at AWS Launchpad at reInvent. If you do have any questions for our panel of guests, please enter those in Twitch chat and we will get to them during the segment. So next couple of questions are about what the experience is like for customers that are using this new service that you announced. So first of all, is this an open source project? And then secondly, how do customers, developers that want to use this capability get started with it?
Yeah, so this is an open source project. We welcome contributions, and you can find us on SageMaker Operators for Kubernetes under our GitHub. You can install these operators on your Kubernetes cluster. So let's say you have a cluster running in Amazon's Elastic Kubernetes service. You can install the SageMaker operators on your EKS cluster. And once the operator is set up, we provided you with sample configuration files that are YAML files, and you can use those to deploy with our operators and set up jobs in SageMaker. So within minutes, you install the operator in your cluster, and then you can be training a 16-node GPU distributed training model without managing any infrastructure.
Great. And just so I'm clear, the experience for a customer is they're using the Kubernetes API or configuration files to run these execution jobs, and also for inference jobs as well, right? So you can
That's
create
right.
inference endpoints as
So
well.
using the same Kubernetes API and command line tools like kubectl,
Yep.
you would set up your jobs and deploy them, and they would then execute in SageMaker.
Great, excellent. Okay, so let's turn to Lyft and Keaton, who's kindly agreed to join us today to talk a little bit, not only about this particular service launch, but also give us a little bit of insight into how Lyft use machine learning today. And we'd love to hear a little bit more about your role at Lyft, and also if you could share with us a little bit about how your company, which should be known to everybody, I guess, so it's a popular, very popular, very popular ride-sharing service here in the US.
Thank you.
If you could share a little bit about how Lyft uses machine learning for the audience, that'd be great.
Yeah. Everybody knows that autonomous is like the deep thing about machine learning. There's vision, there's perception, and there are all of these things that make the autonomous car work. But many people forget that at the core ride share has a lot of machine learning too. When you open up your phone, you call a ride, it says 3 minutes to the car. How is that getting powered? That's powered by machine learning. When the car, which driver to pick for this user is powered by machine learning. When is there a potential fraud? That's powered by machine learning. The maps themselves are powered by machine learning. We are actually constantly learning by the cars that are going out there and actually understanding the traffic conditions on the road and constantly improving the experience for the users. And all of this is powered by machine learning. But also, a lot of this is powered by machine learning that is driven by data. So a lot of data that gets crunched in the system, and the interplay of these two together is what I actually work on. I lead a team called Flight, where we are trying to make machine learning and data infrastructure combined into one piece of a system. And we offer this hosted system to all our users at Lyft. And it's purely containerized, it's Kubernetes based. We recently open sourced this 2 weeks ago at KubeCon, and today I'm excited to announce that we are actually working closely with Aditya's team to integrate with SageMaker and offer like a unique experience for all the users of Flight at Lyft and whoever uses it in open source to directly train their models on Kubernetes using any of the existing operators like TensorFlow operator or so on, or use SageMaker operator to train it in the cloud and manage even lesser hardware.
Yep.
So that's the opportunity that I'm doing.
Great, and maybe you could show us a demo. I noticed you've got something on your screen there to show us. So can you take us through the experience for a user of the system?
Yeah, so this is going to be
just increase the size of your text with
Absolutely.
That's cool, thank you.
So what I'm going to do is I'm quickly going to introduce it. We have a session today at 4 p.m., so we'll go in more details over there. But this is the Flight homepage. Flight is essentially the hosted platform at Lyft that runs all of the machine learning pipelines. As you can see, there are you can create projects in it, and you can have domains, just like if you're used to from services. So we click on one of them. What I'm going to demo today is we are going to train a model that uses an open source data set from UCI. And it's predicting whether whether some patient has diabetes or not. The interesting thing about this model is, if we go to to understanding the model, is that it uses structured data. So the data actually is structured, and I don't know if you can see it, but the data is structured. But what I mean by structured data is there are columns that have types, right? And this is what real-world data is. Like there are patient, what's the age of a patient, which is an integer, or what is the pedigree of having diabetes in the past, and that's float. So Flight inherently understands all of this and passes it along, and makes it really easy for the users to declare their functions, which can be any function to write to train a model. In this case, if you see, we are trying to train a model that's for XGBoost, and it's taking the specific schema that we just looked above, and as an input, and it producing a model as an output. So let's quickly run it. And this is how you put the model together. This is actually what we currently refer to as a pipeline or a workflow. And there are a bunch of inputs that you pass into the system. Each of them, in this case, the data, where you get the data from, I'm getting from the open source, that's the default way. The actual, how do you split the data, how do you fit the data and predict on it, and then produce an output called model and the accuracy, right? So let's actually just quickly run this. So this is going to register the workflow in the system. So you have to do it, and it says yes. What we're going to do is cause a launch. If the network helps me, yes, the network is with me. So it's going to go on. And if you saw that the launch, it launched and it already completed. Why did it run so fast? We'll learn about it in just a second. But we can actually continue on, and we can download the outputs from the model. So it actually launched another one, sorry. So it'll take a second to download the outputs, depending on the network. Okay. The network. Anyways, so meanwhile, what's happening is in the background, as the workflow runs, we can go and look at it. These are the steps we discussed: like split the data, fit the task, predict, and then score the task. And the inputs were what we provided, like the open source data set, and the output is the accuracy of the model. So in this case, the accuracy of the model was 63%. Now, if you wanted to quickly change it to use our SageMaker operators, SageMaker provides a hyperparameter optimization engine, and that's what we'll use to even optimize our XGBoost model further. So what the aim is that the 63% accuracy that we saw, let's take it higher, right? And without doing almost anything. What we have done is we have created new plugins that allow you to train XGBoost model with the same sort of syntax that we're used to. You go and train them, you create a new structure. The reason why I've created a new workflow in this case, because SageMaker wants inputs in a specific type. This workflow adapts the inputs of our existing workflow into specific types that SageMaker likes and produces the model in the type that we can use for predictions. So let's do that, but let's not run it here. Let's go back in here, just quickly edit 2 lines of code. And the reason why this works is because the type system understands that the type is the same. So when I just do this, I will go and register it differently. Sorry, and this is just going to take 1 minute, hopefully. And I'm going to launch another execution. This time, this is the execution. It's actually running a sub workflow, and that sub workflow is running on SageMaker. All of them are completing very fast. That's because Flight does an internal memoization system. So I ran this before the demo, and so everything got memoized, and it understands that, hey, you're rerunning this. I won't let you spend the money. It quickly memoizes and replaces the outputs. But if you go back in time, we can actually go and look at some of the older runs, and that'll show you the integration is deep. So this one, for example, almost there. So if you look at the train node, oh, that was the wrong one. So we want to find the ones that have large execution time, so for this one. And in there, if you look at the train node, we directly link you to the SageMaker job that was running in the background. And this was the job that ran, and this is all like all the various parameters that it optimized. And actually, if you go back, it also gives you the logs for that job right in the same plane, and all our users just use basically Flight as the front end, but SageMaker's driving it at the back. And now you can use this model to quickly, you saw the accuracy has gone up to 66%, and that is purely because of SageMaker hyperparameter optimization. And we can now use the model to quickly run more predictions. And in this case, I have one data set, and it says, yeah, that person's likely to get diabetes.
And what's great about this is we've designed these SageMaker operators to be very modular. They're meant to be primitives, so customers like Lyft that have Kubernetes-based platforms can then use these as inputs and abstract and build additional layers of software on top of them. So the way Flight will then use SageMaker operators as a primitive, and then they can decide what type of automation and UI they want to attach to that.
Yep.
So it allows you to make use of your existing investment in software development. You're just plugging out one training and inference layer and plugging a different one in to replace it, essentially.
It's a good question. So when we were building Flight, Flight is Kubernetes native.
Yep.
Because of the SageMaker operators, the integration with Flight became trivial. And we actually made a lot of efforts to make sure that we can integrate with, as the new technology emerges on Kubernetes platform, we want it to be all adapted directly into Flight and available to our users at Lyft.
Yep.
So that was the effort that we put in, and working with Aditya, we were really able to deliver this probably in like a week or something.
Yeah.
Which is pretty
trivial
amazing.
integration.
Yeah. So, and this is only the beginning of the integration. I see this getting integrated further.
Yep.
Cool, good. Pretty light on questions, Twitch. So if you do have any questions for our experts here, please submit them via Twitch chat, and we'll put them to our put them to our panel. Is there anything else you want to add? We've got about 3 minutes left, but I think we've covered everything in the demo that you wanted to cover. So is there anything that you want to add about the service in closing?
Just the SageMaker Operators for Kubernetes are generally available, and you can get them from our GitHub repository. Setup is easy in an installation configuration file that we've created for you, and you can deploy them onto your Kubernetes cluster. Let us know how you're using them. We'd love to hear your feedback. Feel free to create issues and pull requests in our GitHub repository. Contributions welcome in all forms.
Great.
And I like to add that Flight is open sourced. It's available on flight.org. Please go there. You can sign on our Slack channel. We are all ready and eager to help get you started with this. The SageMaker integration has not yet landed into the main line, but it should land soon.
Yep.
Great, excellent. So let's wrap this session up. We'll join you in a couple of minutes. Thank you. Thanks for joining us. We'll see you soon.